Hi and hello. Today we are going to explore something useful, which is the linear programming model. So what is the linear programming model? Linear programming model is method used to optimize a linear objective function. This means we are trying to either maximize something valuable like profit or minimize something costly like expenses under a set of given conditions. So this condition coming from the linear equality and inequality constraints. For example, limited resources, budget, or time. So now, how to develop linear programming model? That we have a 3-step for the linear programming model, which is formulation, solution, and interpretation. By the end of this section, you have a basic understanding of how linear programming model can help in making smart data-driven decisions. So let's dive deeper into the step-by-step for the linear programming model.
Hello, my name is Safina. Let's go through this really million cost problem together. It's about optimizing animal feed for a farmer. So here's the situation. So the farmer needs to prepare a special mix of animal feed to keep livestock healthy during the dry season. So the feed is using 2 types of grain A and grain B. But it's not just mixing randomly. Each batch must meet certain nutritional needs, like this 8 units per protein and at least 10 units of fiber. Type of grain gives different nutrient. Let me break it down. Grain A gives us 2 units of protein and 1 unit of fiber per kilogram, and grain B gives 1 unit of protein and 2 units of fiber per kilogram. So it sounds simple, right? But here's the catch. So the cost of grain A is 50 ringgit per kilogram and grain B costs 70 ringgit per kilogram. So the farmer wants to make the nutrient requirement at the lowest possible cost. That's the challenge. And we can look into the table form too. It helps to visualize. So in short, our goal is to figure out how many kilograms of grain A and grain B we should mix together to meet the nutrient requirement while spending the least amount of money. This is what we call a linear programming minimization problem. And soon we will turn this into a mathematical model and maybe graph it or solve it using tools like the simplex method or graphical method.
So first, we need to define what we're trying to achieve in this problem. The goal is to minimize cost. We are using 2 types of grain. X represent the number of kilograms of grain A, Y represent the number of kilograms of grain B. So the cost equation is 50 times X plus 70Y. So the objective is to minimize 50X plus 70Y. This is our objective function, which means we want to make this cost as small as possible. So next, we have to look at the rules or requirement that call constraint that we must follow. There are 3 constraints in this problem. The amount of protein must be at least 8 units. For this, we have the equation 2 times x plus 1 times y must be greater than or equal to 8. The amount of fiber must be at least 10 units. So the equation is 1 times x plus 2 times y must be greater than or equal to 10. Non-negative quantities of grain, this means we cannot have negative amount of grain. So x must be greater than or equal to 0 and y must be greater than or equal to 0. So step 3, we need to find intercept. Before we can draw the graph, we need to find the intercept, which tells us where the line crosses the x-axis and y-axis. Let's first find the intercept for the x-axis. When we are on the x-axis, y equals to 0. For the first constraint, 2 times x plus 0 equals 8. Solving this gives x equals 4. So the first point is 4, 0, meaning 4 on the x-axis and 0 on the y-axis. For the second constraint, 1 times x plus 0 equals 10. Solving this gives x equals 10. So the second point is 10, 0. Now, let's find the intercept for the y-axis. When we are on the y-axis, x equals 0. For the first constraint, 0 plus y equals 8. Solving this gives y equals 8. So the first point is 0, 8, meaning 0 on the x-axis and 8 on the y-axis. For the second constraint, 0 plus 2 times y equals 10. Solving this gives y equals 5. So the second point is 0, 5. So to summarize, we have written the objective, that is minimize 50x plus 70y. We have identified the constraint that we need to follow. We have calculated the intercept where the lines meet the axis for both the x-axis and y-axis. Now we are ready to graph this line and find the area that shows all the possible solutions.
Assalamualaikum and hi everyone. My name is Muhammad Faiz Daniel bin Nur Falah. Today I'm going to show you how to find the minimum value in a linear programming problem using the graphical method. Step 1. Understanding the problem. First, let's understand the goal. We are given a few constraints in the form of inequalities. This constraint will form an area called the feasible region, and from that region, we want to find the minimum value of an objective function. Even though the objective function isn't shown here, this step focus on identifying the feasible region and intersection point. Step 2, plotting the constraint. Now look at the graph. There are several lines, each one representing a constraint. The purple region show y greater than 0. This means our solution must be above the x-axis. Number 2, the teal region show x greater than 0. This means our solution are to the right of the y-axis. Number 3, the blue line and shading represent 2x plus y greater than 8. And the last, the pink line and shading represent x plus 2y than greater than 10. Step number 3, finding the intersection point. Now let's look at how to find the intersection point between two lines. On the right side of the slide, we are solving two equations. The first one is 2x plus y equal 8. The second one is x plus 2y equal 10. We want to know where these two lines meet. That point is called the intersection point. Here how we solve it. First, we take the second equation, x plus 2y equal 10. Then we multiply everything by 2 to make it easier to cancel later. 2x plus 4y equal 20. Now we subtract the first equation from this. 2x plus 4y minus 2x plus y given us 3y equal 12. From here, we divide by 3, y equal 4. Then we use this value and put it back into the first equation. 2x plus 4 equal 8. So 2x equal 4 and x equal 2. So now we know the two lines cross at point x equal 2, y equal 4. Now you can see this point is already marked on a graph with a red circle. This point is important because it's part of our feasible region. Step number 4, other corner point. Other important corner point are shown here. The first corner point, x equal 0, y equal 8. That means intersection of y-axis and the line 2x plus y equal 8. Number 2, x equal 10 and y equal 0. That means intersection of x-axis and the line x plus 2y equal 10. And the last corner point, x equal 2, y equal 4. That means the one from the calculation. They are the point we test. Step number 3, objective function. Now that we have the corner point, we use the objective function which will be given in the full problem, like minimize z equal 50x plus 70y, to plug in this value and find which point given the minimum value.
Now that we found the feasible region and its corner point from the previous slide, it's time to find the minimum cost using an objective function. Step 1. Understand what an objective function is. An objective function is the formula we want to minimize or maximize. In this case, the function is c equal 50x plus 70y. This formula could represent the total cost where Rm50 is the cost per unit of x, Rm70 is the cost per unit of y, and z is and c is the total cost we want to minimize. Step 2, plug in the corner point. Remember earlier, we found 3 important corner points from the feasible region. First corner point, x equal 0, y equal 8. Second corner point, x equal 2, y equal 4. And the last corner point, x equal 10, y equal 0. Now we substitute each of these points into the subjective function to calculate the cost. Step 3, do the calculation together. Let's calculate each one. Corner point number 1, x equal 0, y equal 8. C equal 50 multiply 0 plus 70 multiply y, and the total is Rm 560. Corner point number 2, x equal 2, y equal 4. C equal 50 multiply 2 plus 70 multiply 4, and the total cost is Rm 380. And the last corner point, x equal 10, y equal 0. C equal 50 multiply with 10 plus 70 multiply 0, and the total cost is Rm 500. Step number 4, choose the minimum. Among all the value, the lowest cost is Rm 380, and it happened at the corner point x equal 2, y equal 4. This means the optimal solution is x equal 2 unit, y equal 4 unit. If we use this value, we can achieve the minimum cost of Rm 380 while still following all the constraints from earlier. Now you learn how to use linear programming to find the lowest cost. Thank you.
My name is Miza Carmila, and today I will be explaining on how to solve the problem of maximum problem by using the linear programming by graph. And now we will go through the question together and gather all of the information to solve the problem. Sarah organized online learning workshop. She offers 2 types, a basic coding workshop and advanced coding workshop. She earns 60 ringgit profit for the basic session and 120 profit for each advanced session. Each basic workshop requires 2 hours of instructor time and 3 hours of technical support. As for the advanced workshop, it requires 4 hours of instructor time and 3 hours of technical support. Sarah has a total of 16 instructors hours and 15 technical support hours available this week. How many of each type of workshop should Sarah schedule to maximize her profit? And now, let's begin by understanding the problem. Sarah organized 2 types of coding workshop. The first one is basic session and the second one is advanced session. Each basic workshop give a profit of 60 ringgit and the advanced session will give a profit of 120 ringgit. And now we could define the X and Y. X represented as basic workshop while Y represented by advanced workshop. Our goal is to maximize the profit. and that represented by the equation of z equal to 60x plus 120y. And for the second step, we will look on the constraint that limits Sarah's choice, as based on the information, each basic workshop takes 2 hours of instructor times and 3 hours of technical support times. As for the advanced session, it takes 4 hours of instructor times and 3 hours of technical support. Sarah has only 16 instructors hours and 15 technical support hours that available. And from this information, we could form two inequalities. The first one is 2x plus 4y equals to 16 hours. And for the second one is 3x plus 3y equals to 15 hours. Also, since she can't run any negative numbers of the workshop, x and y is more than 0. For this is the full calculation to find the intercept for this question. The first equation is 2x plus 4y equals to 16. Therefore, the x is 8 while the y is 5. For the second equation is 3x plus 3y equals to 15, whereby the x is 5, the y is 4. And this point will help us to draw the boundary lines. And now we could draw both of the constraint line on the graph by using the point of intercept that we have solved earlier. For the orange line is represent the 2x plus 4y equals to 16, and for the blue lines represent 3x plus 3y equals to 15.
The intersection of shade area gives us visible region. So in slide we highlighted in yellow. This region includes all the combination of x and y satisfy all the concentrates. So we also have a set corner point where line intersect. One important point is calculated step by step on the right side of the slide. So we are solving the system 2x plus 4y equal to 16 and 3x plus 3y equal to 15. So we solve it by elimination. Multiply the second equation to align the coefficients. So firstly subtract and solve for y equal to 3 and substitute back to find x equal to 2. So the intersection point is x equal to 2 and 3 equal to and y equal to 3. So which is lies within our feasible regions. So this point along with the other lights like 0, 4 and 5, 0, and any corner point of the shade region will be evaluated in the next step to find the optimal solution. Remember, the feasible region is where all the conditions are true at once, and that's the area where our solution lies.
And lastly, we have to evaluate the profit of each corner point that satisfy our feasible region into our profit function, which is z equal to 60x plus 120y. In this question, we do have 3 corner points. The first one is 5, 0, the second one is 0, 4, and the third one is 2, 3. As based on our calculation that have been made to achieve the maximum profit of 480 ringgit, Sarah has 2 optimal scheduling options. The first option is by schedule no basic coding workshop and 4 advanced coding workshop. For the second option is schedule 2 basic coding workshop and 3 advanced coding workshop. Both combination of option give her the maximum profit of 480 ringgit.
So for the conclusion about the linear programming model is linear programming provide a powerful method to solve real-world optimization problems. So by clearly defining decision variable and adjective function and concentrates, we can build a model that represents a real business or operational challenge. So when we solve this model ideographically, we can identify the feasible region and determine the optimal solutions. So from the result, linear programming are just numbers. They guide us to make informed, effective, and optimal decision in areas. So whether we aim to maximize profit or minimize cost, linear programming helps us do it in the most efficient way possible. So thank you for the hear our linear programming model explanation. Bye.